Thank you. Good morning and welcome. In 5 years, 40% of the market leaders of today will not be market leaders anymore. They will not be able to keep pace with the pace of change in our industry. What that means is 60%, 6 out of 10, that's all. The leaders of today will continue to be leaders in 5 years. So how many of you decision makers in the audience want to be in that 60%? That's right, of course you do. And how many of you feel you have the clear picture about the future of your business to get there? Not that many. Exactly, why is that? A lot of that is attributed to the business software that we use today to help with our decisions. It's here, it's in the descriptive part on the intelligence curve. A lot of business intelligence software that we use today is actually not that intelligent. It's a lot of reporting on the past. It gives you insight about the past of your business so that you can infer from it what that means for the future of your business. You have to capture the attention of your customer when they have the intent to buy. A customer walks into a car dealership with the intent to walk out of that dealership with a car. If you send them an email a week, a month, a day, or even an hour later, it's too late. They have already moved on. When they come to your website to look at a product, that's the time you want to cross-sell and upsell. Again, if you don't capture the opportunity then, it's too late. So what do we need? We need truly intelligent software and fast time to insight to be able to get that competitive advantage in this fast-moving market. We're talking about predictive and prescriptive intelligence. Now, what do I mean by that? What I mean by that is software that continuously learns from our environment. New data as it emerges gives predictive insight to you, the decision makers, so you can make the decisions in real time. And a lot of enterprises are here. They're in the descriptive phase, trying to move into the predictive phase. And we're going to talk a lot about what it takes to move from descriptive to predictive and evolve further into prescriptive, which is yet another stage of evolution in the intelligence. Of course, this is a multi-year journey. And we'll touch on different aspects of this. Pardon me? Absolutely. Right. Right. I'll talk about that. So if I don't get to that by the end, please remind me. So we have about 5-10 minutes Q&A at the end. But through the talk, you'll get some sense of what that is. Thanks for asking that question. It's a great one. So my name is Tushar Shanbhag. I'm VP of Products at Adata. Much like you, I'm a decision maker, helping my company, my organization, be in that 60%. And Adata, if you're not familiar with us, we are a Silicon Valley-based big data company, and our singular focus is collaborative predictive intelligence. I'm here to talk about 3 things. 1, the technology journey from descriptive to predictive, how you as decision makers can use predictive intelligence in your decision making today, and how you can prepare for the upcoming wave of prescriptive intelligence by evolving along with this intelligence curve. By the end of this talk, you will feel powerful as decision makers, having the power of predictive intelligence at your fingertips. So let's begin this journey. As we've evolved as a species, as a human species, it's always been about survival of the fittest. It's what it means to be fittest has changed over time. Early on, it was about physical strength. Physically, the most powerful amongst us were the leaders of the pack. They led us into battle. They ruled. They were the kings. The West, with all its military power, conquered most of the globe, and they colonized them for centuries. It was about military strength. In the recent time, it's actually not been about physical or military strength. It's been about intelligence. The leaders of the last century have used the powers of intelligence and influence to mobilize large populations, large number of people, to achieve historic outcomes. Mahatma Gandhi, the leader of the Indian freedom struggle, country of my birth, did not have the physical strength, did not have the military power. He used the principles of nonviolence to mobilize a large population, unify them as a nation to overthrow the powerful British, who had all the military power. That is the power of intelligence. Similarly, in business, it's been about survival of the fittest throughout evolution. During the PC revolution, it was the Microsofts and the Intels of the world who used the economies of scale and the distribution channels to reach a large set of users and customers that took over from the mainframes. During the internet revolution, it was the Amazons, the Netflix of the world, who used the reach of the internet to dominate in their markets and disrupt existing monopolies like Borders or Blockbuster. It's about the smartest use of resources, and that's been the definition of fittest through the evolution of business. Now, anyone have any idea about what the next key resource is in the era that we're in? It's data. Thank you. Yes, it's about data, and the companies and the enterprises and the businesses that make the smartest use of data in this era will be the fittest, and those will be in that 60%. And I've been at the forefront of the data revolution through my career, so I can relate to this from my personal experience. So let's zoom into this part in the data revolution. Let's take a look at where we are and where we're going. To me, the democratization of big data, so that decision makers such as yourself and me can make decisions in real time, happened in 3 phases. The first phase was about infrastructure, the infrastructure that underpins all of the data. I was at Microsoft at the time. I was part of the founding team of Microsoft Azure. A lot of people believe Microsoft started Azure to compete with Amazon Web Services. It's actually not the case. Anyone have a guess on why Microsoft started Azure? It actually started Azure to compete with an emerging search giant out of Silicon Valley, Google. Google was the reigning search power, and they were building a phenomenal online presence by rapidly launching online properties, one after the other. They bought YouTube, they bought Blogger, they launched Maps, and News, and Mail, and so on and so forth. So what we did at Microsoft, we had an online services division called Microsoft Network, MSN. And as part of MSN, we launched our own set of services to compete with everything that Google was launching. But what did we do different? Or rather, what was Google doing differently? What we were doing at Microsoft, we were standing up these services from the ground up, standing up infrastructure with ops and then scaling them out for each new service. And what was Google doing? They had scalable infrastructure underneath. Today, which is commercialized as Google Cloud Platform, they had scalable infrastructure and a simplified programming model for their developers. So the developers were building these services rapidly, tossing them over the wall on top of this scalable infrastructure, and that's how they were rapidly innovating in that space. How many of you remember MSN videos? Exactly. So we didn't have that, and that's why we started building Microsoft Azure. What is Microsoft Azure? That is Google Cloud Platform. Cloud Platform. Yeah. That's the commercial version. That's exactly right. So it didn't exist in that form back then, in the mid-2000s, but now they've commercialized, and the gentleman sitting over there is part of that team. There you go. Show off the logo, why don't you? Yeah. So that was the cloud platforms and Microsoft Azure. Of course, when Amazon Web Services came out. And that led to the cloud revolution, but that was the underpinning of the infrastructure. That was the first phase. And the definition of fittest was the smartest use of scalable infrastructure. And Google won that game, clearly. Now that's infrastructure, and it gets the agility in deployment of that infrastructure for you as the decision maker. It speeds things up, of course. But you make decisions based on data. So really what it's about at the end of the day is data. So while the infrastructure was being built out and the cloud wars were being played out, there was another significant development happening. The technology that was powering Google's data centers, the GFS and Bigtable, et cetera, were being built out in the open source as Hadoop. And pioneers such as Cloudera were commercializing that for the enterprise. Now, I was part of Cloudera at the time, and I remember in the early days of Cloudera, we were commercializing these technologies for the enterprise. We were convincing enterprises to go and store all their data on technologies based on named after animals such as elephants and pigs and managed by zookeepers. Those are some fun sales cycles. While a lot of them were skeptical, they were leaders. They were leaders who adopted this technology. the Netflixes of the world, the PayPals of the world, the Apples of the world, they adopted Hadoop, they embraced it, they used it, all their data to build sustainable competitive advantage. And they are the leaders of the pack today. And the enterprises followed suit. But there's still a problem. The going was slow. These are complicated beasts. These are massive infrastructure environments. And these are batch processing environments, which take a while to compute, to run through data. The cycles were 5, 6, 7, 10 months, 12 months sometimes. Then came the advent of compute technologies, such as Impala, Presto, Spark, most significantly, and more recently, Apache Flink, which brought in-memory computing to the fore. It brought a simplified programming model to do machine learning, iterative programming, that significantly shortened the time to do predictive analytics, to do machine learning on that data. In fact, for the very first time, you had the elements in place to do machine learning at scale. And this was accessible to enterprises everywhere. You could throw as much infrastructure as you want at the problem. Memory was getting significantly cheaper, and you had the compute technologies to do iterative computation in memory. And most significantly, you had the ability to throw all the data that you're collecting at the problem. So these algorithms that had been developed decades ago now had all of this available to get predictive insight from your data for the very first time. And this is accessible to the enterprises at large. So what does that mean? Decision makers in the world, all of us should be rejoicing. We now have the solution. We now have a way to get predictive insight from all of our data. But when I asked the question early on, a lot of hands went down. How many people have a clear picture about their future today? And why is that? So let's do another poll. How many of you today speak machine learning, speak R, Python, Scala, to go off and get this intelligence from data? A few, a minority. And how many of you speak English? Exactly. You have questions about your business in English. You don't speak R, you don't speak Python. But there are those who do. So there's a gap. There's something missing, something we call big intelligence. The big intelligence innovation wave, which connects you and me, the decision makers, with our data, so we can get predictive intelligence out of all that data in real time when we need to make those decisions. Essentially, the problem boils down to one of talent shortage. So the ones who do speak R, Python, Scala, the data scientists and the analyst, they are today very few compared to the other overwhelming trends. Right? You have a few data scientists. They're facing actually two significantly overpowering trends, overwhelming trends, which is one of data explosion, which we all know about, the 10x, 20x, 50x, based on which publication you follow, in terms of between 2015 and 2020. So there's a massive data explosion coming. We all know that. The data scientists are struggling to keep pace with that. At the same time, these data scientists and analysts have to prepare the analytics for us, the end users, the decision makers. And the number of decision makers that are now demanding their time to get insights from all that data is also growing at an alarming rate. It is overpowering for these data scientists. Now, the challenge is not as many of them are being produced. Now, colleges are having courses for data science. They're having majors for data science. But according to McKinsey Global Institute, IDC, et cetera, it is nowhere close to being addressing this problem. So there's a significant talent shortage today, and is going to be in the next 5 to 10 years. So what does that do? For us decision makers, we don't get predictive insights from data when we need it. For the data scientists, they cannot scale. They cannot scale across these two trends. For the CIOs, they cannot hire enough data scientists to be able to keep up with the demand. So that's the gap. That's where the big intelligence gap exists. So what is the solution? The solution really is collaborative predictive intelligence. The ability to get predictive analytics all the way up to the end user. But of course, the end users don't speak R, Python, and Scala, or Java. The end users speak English. So giving the end users the ability to get this predictive intelligence by self-service. So a large majority of them can get the insights that they need themselves. And the data scientists can then focus on delivering these predictive analytics across hundreds of business users and focus their time working with data and keeping up with that trend. Now, Those are two aspects. There's a third very significant aspect, which is that of collaboration. During different points of the workflow, from the time the data is ingested into the system to the time the end user gets their insight, there are several points in which the business users, the data scientists, the data engineers need to collaborate in their workflow. So a real-time collaboration environment where they are using the same copy of data, same environment to work in, is essential to get the time to insight that you need for predictive intelligence. So those are the three aspects that you need. Now, you may ask, what does such a solution look like? So let's jump really quick to a demo, and I'll show you how this can be accomplished today. So let me switch out of my presentation and jump to my browser window. So here, I have a document-like interface where I'm going to connect to a data set which has 337 million rows. And I'm going to play Director of Operations for New York City Taxi. So let's go ahead and start playing with the software. So I connect to this data set. It shows me it's got 337 million rows of data. It's got a smart query interface. Let's turn on voice here for a second. Show first 10 rows of data. There you go. You have a question in English, it gives you an answer right away on 337 million rows of data. So as a director of operations, I see that this data, I can look inside this data and see what's in there. Now, really what I'm interested in is two things. One, I'm trying to understand what drives my fares on a daily, weekly, monthly basis. I also want to understand the impact of revenue, especially with Uber breathing down my throat. So let's go ahead and do some predictive analytics on this data. Let's go and ask questions such as predict, see what we have to work with here, trip fare, using, let's say, trip distance. Let's turn the voice off for a second. Wow. In about a second, you have a prediction for the trip fare, which tells you that every mile that extra that your cab driver is traveling, the trip fare increases by 331. So instantly at my fingertips, I have this information. Of course, I just picked trip distance out of the blue because you can sort of intuitively get that there's a positive correlation between the trip distance. The longer you travel, the more the fare grows. But it gives you an accurate number, an accurate prediction right here. And this is machine learning running behind the scenes. And I have asked a question as a business user using English. Now, there might be other factors clearly that affect the trip distance. And I'd be curious to understand what really influences the trip fare over time. So for that, I'm going to collaborate real time with my data scientist. So my data scientist is in this environment. You see the cursor over there. And my data scientist is going to come and collaborate with me and help me understand which factors influence the trip fare. So I can get a complete picture of what's really driving the fares in New York City. So here she's come in and she's written R code. That's her language of choice. And she's running this R code right here in this environment. So once this runs, we'll take a look at the code as well. But what she's done is she's run a random forest there to find out the different variables that affect my trip fare. So as you saw before, intuitively, trip distance clearly is one of them. But we also see that day of week is a significant influencer of trip fare. We also see passenger count, week of year, and month. And I got this insight collaboratively in about 5 seconds. How powerful is that? To be able to ask a question, to be able to collaborate with a data scientist in real time, get the insights that you know, which would have taken weeks or months prior to this, at your fingertips. So let me go ahead and tell my data scientist that this is exactly what it's looking for. What's more, I'm going to request a smart query to be created as part of this exercise. So that next time, I don't have to go and bother my data scientist. So once I'm happy with this result, the next time I come in, I can ask a question just like you saw before. And I'll get an answer. That's how the data scientists can scale. They deliver predictive analytics, and they can scale across hundreds of us end users, right? And for the cases where we need their help, they can come in and help us out in the context of our analysis. This is real-time decision making. This is getting insights from large data sets using predictive intelligence to make decisions. All right, so my data scientist tells me there's another query she's already created based on our prior conversation. So let me run this. It says forecast. So let me go and see how to do that. Forecast. All right, a helpful auto-suggest here gives me, so I'm going to forecast the revenue, say in the next 30 days of my pickup date time. So just like before, behind this, there's machine learning. There's a predictive model that my data scientist has built. And using this model, it's doing a forecast. So the red in this visualization are the actual values, and the blue are the predicted values generated by the model. So visually, you can inspect that the model is following the actual values pretty well. And to the very right, you see the forecast. You see the forecast of exactly how my revenue is going to change on a weekly basis. And we saw day of week actually impacts the revenue. So this all makes sense to me. And I've been able to do this in about 5 seconds myself. This is the power of collaborative predictive intelligence. This makes me feel powerful as a decision maker. And you as decision makers have this power with you today. Now, a quick anecdote. When we showed this to our design team, so we're big on design, as you can tell. We showed it to our design team. We said, hey, look, you can ask questions in English. You can use voice to communicate with the software, and you can get those answers real time. They were pretty excited. Like, yeah, this is good. This is great. And this is kind of what we are doing today anyway, because a lot of conversations today with people are via text and email. People actually talk more with Siri than they actually do with people on the phone. So this trend is exactly where we want to go. Now, they had a very interesting follow-up question. And the question was, this is cool, but don't the users have to think about the questions as well? I'm like, yeah. But if the software is truly intelligent, should it not be able to think about the questions itself and just provide the answers so the users can get those answers and make those decisions? Absolutely. That is definitely the next stage of evolution. Our engineers are working hard on that concept. And the next time we demo this, you'll see the software looking at the data, how other users are using that data to be able to give you the answers by the time you enter into the software. So this is the power of predictive intelligence. This is how we further shorten the time to insight. So a new definition of fittest is emerging in front of us. That is about fastest time to insight from data. That is what data intelligence is all about. And the winners of tomorrow, the ones who will be in that 60%, will be the ones who leverage this power to make their decisions. And you have this power today. So let's switch back to the slide deck. And let's see where this is taking us. All right. So far, what we have seen is a journey from descriptive to predictive. And what we've also seen is what tools and technologies you have available today to make your decisions. What we're going to talk about next is where this is going and how you, as leaders in your organizations, decision makers, can prepare yourselves to benefit from this wave. So the intelligence wave is evolving in interesting ways. And we experience the power of predictive intelligence in our lives every day, actually. When we go to Amazon, when we go to Alibaba, when we look at a product, and Amazon or Alibaba gives you a set of related products to say, hey, you might want to buy this as well. That's predictive intelligence in action. When you go to Netflix, you watch a movie. It gives you a set of recommended movies for you to watch next. That's predictive intelligence. And that's capturing the customer's attention when they have the intent to buy, when they have the intent to watch, when they are engaging with you. The data, as it's being generated, is being analyzed. The software is continuously learning from new data from your environment and sending signals back to capture the customer's attention, to upsell, to cross-sell. When we talk to our mobile phones with their assistants, and if you're like me and if you've been in Silicon Valley, when you see those self-driving cars from Google driving around by themselves and freaks you out, that's predictive intelligence in action. So what does that mean? What does that mean for the next phase of predictive intelligence? How is all this happening? So I've kind of simplified this down into this picture where when you interact with the software, with the end software, there are learning widgets as part of that software on your mobile device. So when you browse for a product, when you watch a movie, those signals are continuously being transmitted back to a central learning engine, which is continuously learning. It's got a set of models based on what it's learned already. And those models, those predictive models, continuously get updated with the new data. And they spit out a set of recommendations or a set of outcomes, if you will. And those outcomes are then transmitted back to the learning widgets. And you see your new recommendations. You see the new related products and so on. So that's the continuous learning loop that's built out in some of these companies we talked about, right? And this continuous learning loop keeps learning in the sense that if you don't buy those products, if you don't watch that movie, it learns that those recommendations were not good. It figures out why they were not good, and it updates those models. So the next time you come and watch a movie, you'll get a better recommendation. And that's how it continuously improves over time. And it's this continuous learning engine that is getting built out in some of those companies. And this is the next phase of evolution of predictive intelligence. So it's not one application in terms of the operations that I mentioned. It's marketing, it's sales, it's product, it's customer service, it's customer support. All of that will be influenced by this continuous learning engine. So you can provide better and better and better customer service and engagement to your customers. Pardon me? Correct. Great question, great question. Thanks for asking that. That actually gets to the crux of what we're talking about, which is data is arriving across different, so we just use the example of something that everyone's familiar with, like Netflix or Amazon, right? That doesn't have to be the case. In a banking industry, for example, data is getting collected. There's so many touch points with the customer, right? So data is coming in. It doesn't have to be on an iPad, though a lot of banking applications are happening on mobile devices these days, right? So these inputs are coming in. What happens is, based on the data and based on the domain knowledge in these verticals, you will build these models. So the intelligence is captured in these predictive models, and that's part of this learning engine, right? So the data scientists are building this into the model. So there's a starting point of this engine, right? But when new data comes in and you get the feedback that the prediction that you made or the recommendation that you made is actually not a good one, that feedback comes back and the models get automatically updated. Right? So that's the cycle. Great question. Thanks for asking that. Very pertinent. So it's and a related point, actually. Thanks for bringing that up. It's actually not just restricted to the online businesses. You're seeing examples of this in every industry. Leaders in every single industry are adopting this paradigm and building out their continuous learning engines across different aspects of their business. Correct. Right. So there's multiple challenges. That's a great question, actually. So I got a reminder for 5 minutes. I got 2 more slides, and then we'll come to that question if that's okay. So let me quickly wrap it up because we're going to run out of time otherwise. So we're seeing these examples in front of our eyes. In fact, if you look at self-driving cars, I mean, Google and Tesla, they are technology companies. Apple, for example, is a technology company. They have declared their intent to go build cars, right? So there's this wave of conversions coming as well, right? So there's lots and lots of evolution here. So it's not just restricted to the online businesses. But the final point that I really want to make is this is affecting us today, and the leaders amongst us are adopting this today. We have the data, we have the experts, now we have the technology. So you have everything in your power today to be part of that 60% and go ride that wave from descriptive to prescriptive. So we have about 4 minutes, I think, for questions. Let me take this question first. So the question, if I want to...
So what are the challenges with implementing the continuous learning engine when you have to incorporate feedback back into the engine to make smarter decisions and automate predictions?
Correct. So, so there's some technology challenges and there's some cultural challenges, right? So the technology challenges are at multiple levels. So one is on the like when you have the data and sort of the big intelligence part that we talked about. So that technology is being built out. You saw a glimpse of this. We can talk in more detail later in terms of what are the next phases in terms of deploying this model behind an API that can be called from the widgets, right? So that you don't have to build this out and then code it into an application that then goes and faces the end user. You have a simple API that can directly be called.
So I'm more interested in you have a traditional analytical life cycle where you effectively continuously optimize the models and then put that in. I think what you're talking about here is more continuous learning.
Exactly.
Learning models.
That's right.
Actually immediately improve based on the feedback.
Yes. That's actually the second part, which has got to have, once you have this ability from a technology perspective, there's got to be an adoption cycle and a behavior change. So that's the other part, which is happening in front of us as well. So there is some amount of plumbing that needs to be put in place, and a lot of that is. And then there's the cultural shift from using that traditional model, from building the models and then passing it over the wall, coding it into an application, and then that application goes, and that's multi-week iterative cycle. Now, once you have this ability to have a continuous learning loop and an API that you can just call, you no longer have to go through that cycle. So you have a much simplified cycle here.
Yeah, but you spend a little bit more time in building that learning engine and model to be able to respond to those events.
In some sense, yes, but it's actually, the correct answer here is it depends. It depends on the kind of model, the kind of applications you're building. So it can't be universally that this takes more time. But of course, what it's doing is it's simplifying the ability to build these models on large data sets. So you're no longer building these models on a 1% sample and then generalizing this across the application. You're actually building this model by incorporating all of your data, right? And you're doing that in a collaborative way. You can publish it across the enterprise. So that's fundamentally what's changed here. And that's going to require some amount of change in how you consume the output from the workflow that you described today. So that is definitely the workflow that we have today. There's one more gentleman there, and I'll come back to you, I promise. Yes, please. That's exactly it. Great question. Thanks for asking that. That is actually the fundamental problem that we're solving. So if you saw in the example in the demo, what you saw was a data scientist building a model and then publishing a smart query so that 100 end users can come in and ask that question themselves without going back to the data scientist. So now how does a data scientist's life change? So they keep working with data. They're not building reports and dashboards anymore. They're building what they love to build, which is working with data, building those models, finding those patterns, right? And then they publish it to everyone that needs to consume that, right? And they come in only when they are needed, in terms of when I requested my data scientist to come write some R code. That's when she came in, wrote some R code. And now the next time, she's going to codify that into a smart query. So next time I can ask that myself, right? So I had a one-on-one interaction with my data scientist, but 99 of my other colleagues will not. Right? So that's what helps the data scientist scale across 100 users versus this one-on-one. Right? And they no longer have to build the reports and dashboards because I can do it myself. Like I know how to use Word, I know how to use documents. So it's in my familiar environment, I can speak English. And if you give it to me in a way that I can use it, I will self-serve all day. Thanks for asking that. That gets to the exact core of how we're solving the talent shortage problem, how we're helping the data scientist scale. Yes.
Collaboration is
yes.
very important. How do you see solutions evolving to enable that collaboration to happen, during the especially development and design phase?
Yeah.
I've seen a lot of analytical BI tools
Yeah.
which kind of neglect the collaboration aspect of it, and at the end of the day,
Absolutely. Great question. Again, thanks for asking that. That is actually one of the phases of evolution. We talked about the descriptive nature of the business intelligence tools, where you're looking at the past of the data and you're doing aggregations and so on, neglects the collaboration. Here, collaboration is so fundamental because I could not have written that R code myself, right? And if I have to wait for 6 weeks to get that R code, I need to make that decision now. It's too late for me, right? So that fundamental aspect of collaboration is one of the things that differentiates this wave. It is needed. It is needed for the promise to materialize, right? And the collaboration is actually at multiple levels. It's not just me chatting with some person. It's multiple chat applications. It's actually having an environment where we are working on the same copy of data, right? We're working with the same models that all of us can share, right? We're working the same applications, so we're sharing the context and our thought streams, so that we are in the context of the analysis at multiple stages, different people come in. Much like if you build a PowerPoint yourself, collaborating with your colleagues, different slides come from different people at different points, you have a presentation. The same concept in terms of an analysis, at different points you need help. And then the real-time nature of that, where everyone's working on the same copy of data versus somebody going and taking a 1% sample in their single node environment and then coming back. So that's at multiple levels of depth is where we need the collaboration.
Do you see that currently as a gap in some of the tools and the solutions?
Absolutely.
Collaboration is kind of neglected?
Absolutely. Absolutely. It's hugely neglected. Well, there are aspects of collaboration people call collaboration, but the collaboration I'm talking about where there's a single copy of everything.
It means more integrated collaboration rather than outside that development life cycle, which is important.
Correct. Correct. Yeah, great question. Thanks for asking that. So that is, so the collaboration part and the ability to democratize the analytics, the predictive analytics part, and the ability for the end users to do self-service. So we can get the insights we need and the data scientists can scale to enable us to do that. That's really what liberates and democratizes big data. And that's the new definition of fittest. Those who can do that, those who can capture that value, those who can shorten that time to insight and ride that wave will be part of that 60%. All right, thank you very much for questions. I'll be available here after if you have more questions. Thank you.